Hi guys! This is the second part of the double-side PCB creation tutorial.
In the first video, we generated the G-code files to realize this circuit.
And today we use the ant to make it.
So, let's start. We are starting from a situation where we already performed some preliminary operations. In order, these operations were: opening BCNC, power on and connect to the machine, perform a numbing procedure, set the X and Y working 0, probe and set the Z working 0, open the .gcode file. If you have any doubts on how to perform any of these operations, we leave a link in the cards to an useful playlist with videos that describe them. Notice that we are using the new head with the pre-connected probe cable. In any case, remember to connect a probe terminal to the surface of the board, and if you don't have the pre-connected probe cable, you need to connect the second probe terminal to the bit before every probe and auto level operation. So, from this point we get the margins, set the grid spacing and launch the scan procedure. Set the Z-axis to 0 again at the center of the grid and also set the 0 of the auto level. Then we are ready to launch the milling procedure. When the milling procedure is done, we are ready to make the alignment drill. But first, a tool change is needed to insert the drilling bit. As a consequence, we perform a new probe to set a new 0 of the Z-axis and we load the top alignment drill G-code file. When you load the G-code file, answer no to every question, so that the bed level information are retained. Launch the alignment drill. BCNC needs to know the offset between the tool and the camera to perform an optical alignment. This operation can be executed using an existing hole or drilling a new hole on the board. In this case, we show the offset calibration on an empty board. We drill a hole on the XY0 working position. In this point, we mark the position of the spindle in the probe camera panel. Then we turn on the camera and align the center of the crosshair circle to the center of the hole. At this point, we mark the camera position in the probe camera panel. To obtain always the maximum precision, we suggest to execute this operation before every optical alignment. This phase starts after turning upside down the board and loading the bottom align drill G-code file. We switched on the camera and we go in camera mode pressing the button switch 2 in the probe camera panel. As stated in the previous video, we will use the alignment drill to obtain the rototranslation information to orient all the bottom side G-codes. To do this, for each hole, we align the crosshair of the camera with the center of the hole. Add an alignment point to the probe panel and click on the relative G-code point on the screen. BCNC automatically snaps on the nearest point in the G-code. At the end, the rototranslation information are calculated and stored in BCNC. At this point, we need to perform the auto level on the bottom side, and we load the bottom profile G-code just to do that. As you will see, it's the same procedure made on the top surface, but preceded by the G-code alignment that is executed by pressing the orient button in the probe panel. We load the bottom drill G-code. Press the orient button and start the drill operation. After a tool change to insert the milling bit, and after having zeroed the tool, we load the bottom G-code file, press the Orient button and start to mill. The last operation we execute is the board profile cut. As usual, we change the bit with an appropriate one, set the tool 0, load the bottom profile G-code file, press the Orient button and then start the cut operation. After the whole process, this is what we obtained. It may be necessary to use some fine grit sandpaper to brush it lightly to the burr.
So guys, we show you how to make this kind of circuit, but it's not the only way.
If you didn't watch the first video, you'll find it here.
Ah, well played!
Okay, please subscribe.